Hi, my name is Varun, and I'm currently a junior in high school. Today, I'm going to be showcasing FIRES, or the Forest Ignition and Risk Evaluation System. So, without further ado, let's get into the demonstration. So, this is the main UI for FIRES, and as you can see, it is extremely user-friendly. It starts off with defining what FIRES is and explaining it, and then lets me drag and drop a file to analyze it and then see if there is a chance of a fire in that image or not. So I can add an image over here just by dragging and dropping it. And as you can see, it inputs the image and then it shows me analysis results. The machine learning model that powers fires, specifically a multi-layered perceptron model, was trained on over 40,000 images from the Canadian Wildlife Ministry, and it determined that there's not a high chance of a wildfire appearing in this image. As a result, it gave us some recommended actions, such as continuing routine monitoring, maintaining regular satellite imagery, keeping fire prevention protocols, and documenting conditions for historical baseline data. So I just added a second image, image 2, and it's a satellite image of a forest. This time, the model determined that there's a wildfire detected in this area, meaning that there's a high chance of a wildfire appearing in this area in the future, with immediate action required. And once again, it gave us 5 recommended actions, those being contacting local fire authorities, alerting nearby communities, deploying additional data, coordinating with fire suppression resources, and monitoring wind patterns. If we head to the analytics section next, we can see summary statistics of all the detections that we've been doing. So we did 2 total analyses with 1 fire detected in 1 clear area, meaning there's a 50% detection rate. And we can see the recent analyses. Lastly, in the About section, we can see an overview of how FIRES was created. So we can see the technical architecture, being its machine learning model and how it works. We can see its model performance with an accuracy of 97%, which is extremely high based on the data it's been trained on, and its use cases. The truth is, most machine learning models used by Texas and the government to predict forest fires do not have good predictive capabilities. They rely on using topographic data to find fires that have already happened. Fires could save thousands of lives every month, as well as millions of dollars in property damage, just because of its predictive capabilities, while also being extremely low cost and very efficient. Next, I want to go over the code that developed fires. So this Python file is what's been used to develop fires. It was developed with CSS and Python, with CSS used for styling and Python being used for the machine learning model. It's around 306 lines of code, and I specifically use Streamlit, which is an open source library for Python developers. Thank you so much for considering me for the 2025 Congressional App Challenge.